All right, guys, do you see how your number 2 is a little bit different than the 2 I have up here? Change yours to match mine. And then I think this problem is number 3 on yours. Is that right? This one? Okay, and then change that to match that. Can you guys see okay? I'll move it up as much as I can. So make sure the first 4 questions on your notes match the 4 questions I have up here. We did some editing after I already copied, so sorry, guys. Yeah, your number 3 is what I have for number 4, and then that's different. So however you want to make all 4 of these appear on your paper, I don't care. Just make sure all 4 of them are there. What?
So the one that's represented that one, should we add that?
Yeah, like if you want to replace the number 4 on your paper with that.
Oh.
Do you see what I mean? Because I think your 3 is my 4. I have no idea why. That seems way complicated, but it is what it is. Mm-hmm. Yes, I added the squared outside of the parentheses. Are we ready, guys? Okay. All right, so we are solving nonlinear inequalities here. The inequality, that's the greater than part, or less than, greater than or equal to. And then you have to solve it. You have to tell me which x values this works for. So the method we're going to use is called the number line test. So I'm going to draw. Ooh, maybe I'll draw. Draw a line. This first problem here, I'm going to end up with 2 numbers on my number line. Any guesses as to what those 2 numbers are going to be? Yeah. -1 and +6. You are correct. How did you figure that out? Yes. We are figuring out where each factor equals 0. Okay? Then what we have to figure out is the regions of our number line. Are they positive or negative? And what we're looking at is the product of those 2 factors. Does that give me a positive or a negative number? So I have to test the regions. So I've got -1 up there. I need a number on the left side of -1. What's the number left of -1? -2, -5, and -87. Yes, all of those are fine. Just has to be on that side of the number. So if I do -2, what I'm doing with this is plugging it into this first factor. So if I do -2 minus 6, what does that give me? -8, right? Which is a negative number. That's what I care about. So I'm going to put a little negative sign in parentheses. And then I'm plugging it into the second factor. So -2 plus 1. So also negative, right? But remember, what we care about is the product of those 2 numbers. So a negative times a negative is positive. So I'm going to put a big plus sign right there. So overall, that region of my number line is positive. Okay. All right, so now I have to move on. Between -1 and 6. What's a nice number in between -1 and 6? 0, yes. So same thing. I plug it into each factor. So put the 0 in here. What is 0 minus 6? Okay, negative. And 0 plus 1? Should I plug it in here? Positive. What is a negative times a positive? Negative. Are you catching on? Okay. All right. This side of 6, over here on the right, what do you want to use? 7, 8, 9. All of those would be just fine. So 7 in the first parenthesis, what do I get? 1. So a positive number. In the second parenthesis, positive. Positive times positive is positive. Okay. So we have all these little pluses and minuses, but we haven't answered the question yet. It is asking me, when is this greater than 0? Okay. So do you think I want positive answers or negative answers? Positive. So I want the parts of my number line that are positive, which was over here. Over here. Now I'm fully aware that numbers in this section are negative, but the product of the two factors in this area is positive. That's what we're talking about. What do you think? The -1 and the 6, do I want to include those or not? No. Why? Right. It just says greater than 0. It doesn't say greater than or equal to. So I'm going to put little open circles on those. And then we just have to write our answer in interval notation. So I start on the left. Negative infinity to -1, parenthesis, union 6 to infinity. Okay. Another way you guys can think about this, you know our graphing polynomials, the first standard, one you just did the retake on? If we graphed this, I would know that it's going to cross at -1 and cross at 6 and do something like that, right? So between -1 and 6, it's below the x-axis because it's negative, okay? Over here it's above, over here it's above because it's positive, okay? So you can think about it either way. If the graph makes sense to you, do that. All right, questions so far? Okay, let's try again. All right, number 2. It's set up where you have a 0 on one side. That has to happen. This one's not factored for us, though. Can we factor it?
Yes.
Yes. What does it factor into? Okay, and then your actual factors. -1 plus 5. I just do the guess and check straight to the answer sometimes, okay? If it takes you a minute to get there, that's fine. We're okay with those factors? Okay. All right, you're going to do the rest. So make your number line. I guess I'll make sure you have the right numbers on your number line. What are we going to put on there? Okay, good. And make sure you always put them in order. All right, so I'll give you a minute. See if you can solve this one. Be sure to ask me if you're stuck on anything, all the pluses and minuses. All right, so when I plug in, let's say -6, I end up with a negative times a negative, which is positive. All right, if I plug in a 0, negative times positive, which is negative. Say I plug in 1, positive times positive, which is positive. Okay, so a couple of things with that. You guys at this point are probably like, all right, does it always just go positive, negative, positive? Should I just write that every time? No, it does not. But you can definitely take a shortcut. If you are like, that is very tedious checking every single section. You can use what you know about polynomials and multiplicity. You see how none of these factors have like an exponent on the outside? Okay, so you know based on the graph that it's just going to cross the x-axis at each of these points. So once you know one region, yes, it is going to alternate positive, negative, positive. If this has a multiplicity of, say, 2, is it going to alternate? No. Why? Because it bounces. So if it was positive, it's going to go back and stay positive. Okay, so you can quicken this up a bit if you think about what the multiplicity is doing to your zeros. If that seems overwhelming to you, then just lots of pluses and minuses, okay? You can certainly do it that way. This one, then, we need to write our answer. I know some of you still looked at, it said less than or equal to on your original problem. I'm looking for greater than 0 now, though, so I want the positive parts. Positive. And am I including -5 and 1? So your answer, -∞ to -5. Okay? Where are I with that one? Okay. Let's look at 3. What's different about 3? Well, my number 3. What'd you say?
There's an X on the outside.
Okay, so we've got like an extra factor, right? What else is happening? Multiplicity. Yeah, we got a lot of stuff going on here. So my number line is going to have 3 values on it because there's 3 different places where that's going to equal 0. So what are the 3 numbers? Okay. All right, you guys try from there. Think about what the multiplicity does. Or just test every region. There's just lots of regions.
Yeah.
The line keeps going, it doesn't go, it's different if it went down.
Guys, interesting. 0 and 1, if you're plugging in values, you have to pick a fraction. Remember, you don't have to figure out the exact value. You just have to tell me, is it positive or negative? It's like words away. Yeah. Okay. Does that make sense? Should I worry? What? So you're actually going and getting brownies every time?
Yeah.
Why are you telling me this? All right. Okay, guys, let's look. All right. So if I plug in, let's say -4. -4 in that first factor is going to be negative. -4 in the second factor is negative. Now, guys, this factor is squared, so what is it always going to be? Positive. Good. All right. Negative times a negative times a positive. Good. Positive. Okay. Even number of negatives is positive. All right. So if I know what multiplicity does, I can just fill in the rest of the chart. -3 did not have multiplicity, so I know it's going to alternate after that. 0 did not have multiplicity, so it would alternate. 1 did have even multiplicity, so it's going to bounce and do the exact same thing. Again, if you're like, no, that scares me, that I'm going to screw that up, just test all the regions. That's fine. Okay? Are we okay with the plus and minuses and all of that? Okay, then we have to actually write our answer. I want to know, when is this greater than or equal to 0? So positive stuff. Positive, positive. It says or equal to 0, so I also want to include the -3, the 0, and the 1. So writing my answer, I can just say -infinity to -3 with a bracket. And then 0 to infinity. You don't need to say 0 to 1 and 1 to infinity. That is very redundant. Don't write it that way. Okay? It starts at 0 and just keeps going. How many of you got that one? I didn't get to see everybody's on that. Pretty close? Okay. Making sense? All right. Let's look at my number 4. I don't know what number it is on yours. 3. Some of you rewrote it, so it's all on the same problem. All right, whenever you are doing these inequalities, the first thing you have to do is get a 0 on one side. So I'm going to bring the 10 over. Okay, and I know a couple of you were working ahead and you were like, it doesn't factor. That's correct, it does not factor. Some of you even went ahead and did the quadratic formula and saw there's only imaginary solutions. That is also correct. So let's think about what this is telling us. Do you know what graph an x squared is? Like what shape we're talking about? Yeah, parabola, right? Okay. Is this an upwards facing one or a downward? Up, because it's positive. And guys, do you see how every other number is positive? They're all positive. That means the graph has been shifted up. I don't care by how much. I just know that it's somewhere up here. Okay? Are you with me on that? All right. The question is asking me, when is it greater than 0? That means, when is it above the x-axis? Okay, that's your answer. Yes. Now, what if I had asked you, when is it less than 0? Never. Yeah, no solution. Okay? So if you get to 1 and you're like, that does not factor, it's probably one of these all real numbers or no solution types of questions. Okay, so just look at those. All right, we're okay with that one? Does that make sense? Because we know it's facing up, right? And then everything is positive. So if we actually put it in the form where you can see, you know, the vertical shift, all of that, it would be shifted up. You know?
Yeah.
And I won't give you ones where you actually have to find the detailed version of the graph. You just need the general idea of, oh, that's up here somewhere. So it's not going to cross the x-axis. Okay? All right, let's look at year 5 and 6, right? Okay, are these what year 5 and 6 say or not? Okay, change them please to match me. We do have a fire drill this morning, guys. It's supposed to be at 9:40. We'll see if that's what happens. It was going to be during Warhawk time, so I don't know why they shifted it to like 5 minutes earlier. But okay.
There's an and, it's just on my nose.
Weird. All right, guys. Clearly, these look different, right? Always fun with fractions. Yes, we love fractions. No, we hate fractions. All right, let's look at number 5. So again, it's the exact same idea that you need a 0 on one side. So the first thing I have to do is subtract 3. You can put it over 1 if that helps you. And yes, I left some space there. All right, if I'm going to subtract fractions, what do I need? Common denominator. What is that denominator going to be? Okay, so this 3 over 1, I need to take the numerator and the denominator times x plus 4. That's how you make common denominators. All right, so then I'm going to make one big fraction here. I know my denominator is x plus 4. my numerator, the x minus 3 stays as is. And then guys, realize you are distributing a negative 3 to that x plus 4. So you're going to get minus 3x minus 12. And then greater than 0. Everybody okay with those negatives? You see what's happening there? Okay. All right, so I can simplify the numerator. What's x minus 3x? Good. And negative 3 minus 12. Negative 15. All over x plus 4. All right. Now it's the same idea with the number line. Any guesses as to what the two numbers on my number line are going to be? Negative 15 halves, right? You can tell me negative 7.5 if that makes your brain happier. And what's the other one going to be? Yeah. Is everybody okay with how it's negative 15 over 2?
Yes.
Okay, you're setting that equal to 0, thinking about it. Yeah, we're okay with that. All right. So that would go over here, negative 15 over 2, and then negative 4. All right, so same idea with the testing of your number line. I don't really feel like testing every single region. Do you see multiplicity on anything? No. So once you find one section, it's definitely going to alternate from there. What's the easiest number to plug in? 0, right? Isn't 0 going to be the easiest thing? Okay. Where is 0 on the number line I've drawn? Yeah, it's way over here on the right this time. Okay, so if I plug a 0 in, I get a negative 15 over a positive 4. So is that a positive or negative fraction? Negative. What's going to happen with the rest of it? Yeah, so positive, negative. Okay? Are we okay with that? Again, plug them in if you want to. We're just running out of time, so. Okay, I want to know, where is it greater than 0? The middle this time, yeah. Okay, am I including the 15 halves in the 4?
No.
No. So, parentheses, negative 15 halves, negative 4. Okay? Yeah.
How would it look if we had a graph?
Yeah, so if you actually graphed this, you'd have like a vertical asymptote at negative 4. It's one of those weird, like that kind of thing. But that's, yeah, so I wouldn't graph these. Not yet. That comes in a little bit, okay? Don't expect you to remember those graphs. Are we okay with the number line part of it then? Okay. All right, I think we can get through 6. Let's try. Okay, so what's my first step? Perfect. Bring that 6 over.
Please pardon the interruption. This is Mr. Hood. Good morning, staff and students. In just a few minutes, we'll conduct our second fire drill of the year. We are required by Virginia Code to conduct a fire drill for the first 20 days, once a week, and then once a month thereafter. I hope the video conducting the fire drill on the Madison News Network this morning was helpful. We will continue to monitor our procedures and refine as appropriate. Faculty, please take just a few minutes at this time to review fire drill procedures with your class, and then once the alarm sounds, we will begin our drill. Thank you.
Okay, we go to the 25-yard line on the football field. We're good. Okay. Okay, guys, are we here? Did you get the distraction? I realized I just kept going, and I may have gone faster than you. Did you get it? Are all of your signs right? guys, what are the numbers on my number line? 3 and 4, because it'd be negative 20 divided by negative 5, so 3, 4. I'm going to plug 0 in, which would give me positive over negative, which is negative. Alternate. I just want to get to the answer quickly to show you one thing on this. It says less than or equal to 0, right? So that's the negative parts, and the positive, and the right side here is negative. It says less than or equal to, so am I including the 3 and the 4?
Yes.
Okay, careful. Am I including both of them?
I guess not.
You're like, oh, well, you asked me. Yeah, so no. Which one can I not use? The 3. Why? Yeah, the 3 would give me a 0 in the denominator, right? Oh, yeah, that's not okay. So tricky, not included, is included. So your answer is actually negative infinity to negative 3 parentheses. Then bracket, oh, it's not a negative 3, sorry. 4 to infinity. Okay, I know that was quick on that last one. I just wanted to show you that part. So don't blindly trust it. Homework. You get to skip a couple on standards free homework.